Hello students, my name is Dr. Mallikarjun. I am belongs to Department of Information Technology in Institute of Aeronautical Engineering. I am giving the series of lectures on operating systems. Last videos I explained what is operating system, what's the objectives and functions of operating systems and various advantages of operating systems. I explained various operating systems I explained in the last videos. Today's I am explaining about process. So what is process? What are the functions of process? How it perform in operating system? That and all we will see in this video lecture. Process. A process is basically a program in execution. The execution of a process must progress in sequential fashion. So process is defined as an entity representation, the basic unit of work to be done. To put in simple terms, we write our computer programs in a text file, and when we execute this program, it becomes a process which performs all the tasks mentioned in the program. So program is different, process is different. So that is a process is an entity, means that a process is a execution of a program. So program is different. Once a program runs, that you can run the program, that become the process. The execution of a program is a process. Okay. When a program is loaded into the memory and it become a process, it can be divided into 4 sections. So stack, heap, text and data. So the following image, I'm showing the next slide, that image, the process of image, I'm going to next slide. But now we are going to basically observe that a process have 4 sections. One is a stack, second one is the heap, and third one is the text, and fourth one is the data. That we will see in detail about that main structure of the process. So that can be shown one image in my coming slide. So this is the main table of that 4 sections of the process. That first section is a stack. That is the main component of the process. Stack. The process stack contains the temporary data such as method or function, parameters, return address, and local variables. This is a stack. Heap. This is dynamically allocated memory to a process during its runtime. That is a heap. Next section is the text. This includes the current activity represented by the value of a program counter and the contents of the processor's registers. This is the third section. That is a text. Fourth is a data section. This contains global and static variables. This is the data section. So these are the main components of the stack of the 4 sections. So each giving the description in this slide. Next, this is the image how the process structure has been depend in this slide. A stack section, heap section, text and data. The following image shows a simplified layout of a process. This process consists of the inside a main memory. This is a figure: process, stack, heap, text and data. In between that there is a shrink. It is going to be shrink. This area is going to be shrink depend upon the size of the stack. It going to be decrease, it going to be decrease, or it going to be increase. Depends. It depends. That main depends on the stack. That heap, in between that there is a gap of the processor. Shrink and heap section. So this is the image. Mainly layout of a process happens inside the main memory. So the process works inside the main memory. So this is the structure of the process. So in between that there is a huge gap. This gap mainly shrink or extends, depends upon the size of the process. Some process has oversize, it extends. Some process have less size, that time it shrinks. Next slide. Now coming to a program. A program is a passive entity that has a set of codes and instructions required to accomplish a task. A process, on the other hand, is an active entity of a program that is started with the execution of a program. Thus, the process is started by the program. Once it is executed, the instructions of a program are then executed by the process. So main here in this slide explain that the main difference as shown in this slide. The difference between main, program and process. So in this definition, program is a passive entity. Here I am defining program is a passive entity. So what happened the process once program is a passive entity? So that if program is a passive entity, process becomes the active entity. So that is the main difference in between the program and process. So the process is started in the program, started by the program. So once it is executed, so the instructions of program are then executed one by one as a sequential manner of in a program. That becomes the process. A program is a piece of code which may be a single line or millions of lines. A computer program is usually written by a computer programmer in a programming language like C, C++, Java, any programming language. So let me say one example of a simple program written in C programming language. The first C programming language start with the hash include stdio.h. This is a header file. Every program start with any one of the header file. This is the basic header file, standard input output header file. Then coming to the main function that returns the integer value, so that int main function and start the bracket. Then start a statement of printf hello world. This is a printf statement. Then goes to return 0. Then end of the main program. So this entire thing is a program. Once you type this program and save it. So once you type this program and save it, this entire become the program. So once this program has saved, then it's going to be run. Once you run this program with the instruction ./a.out, that any instruction, you can run this program. This program become the process. Once you runs that program becomes the process. That's why a program have single line or one line or two line, a millions of line, then it started for the execution. That program become the process. So that is the main intention here. I'm explaining that differentiate between process and program. Okay, let me go to next slide. So here I am giving the table of complete differentiate between the process and program. Program, it is a set of instructions that has been designed to complete a certain task. Set of instructions, it may be one line. Last slide I am explaining it may be one line, two lines, or millions of lines. That is a program. Coming to process, it is an instance of a program that is being currently executed. Program is a passive entity. Process, it is an active entity. Program, it is resides in the secondary memory of the system. It is created when the program is in the execution is being loaded into the main memory. So last slides I'm explaining this is the first point and second point, and this is third point. Coming to the fourth point, a program, it is exist in a single place and continue to exist until it has been explicitly deleted. So this is the main differentiator between program and process. Coming to process, it exists for a limited amount of time and it gets terminated once the task has been completed. Coming to the fifth point, it is considered as a static entity. Coming to a process, it considered as a dynamic entity. That is the main difference. Program is a static entity, process is a dynamic entity. So static means before execution, that's why it is a program. That's why it is a static entity. Once it got the execution, it becomes the dynamic entity. Coming to sixth point, it does not have a resource requirement in the program. It is a high resource requirement in the process. Coming to seventh one, it requires memory space to store instructions. A process, it requires a resource such as CPU, memory address, input output during its working. So means that a process inside the main memory, that is depends upon the resources like CPU, memory, input output. These are the primary resources. That's why a process completely depend upon the resources. But program depend upon memory space only. So this is the main difference. Coming to the eighth difference, this is the last difference, eighth one. So it does not have control block. Coming to process, if it has its own control block, which is known as, that control block is called process control block. So again, process control block have various data structures that I will explain in my next video or my coming videos in detail about the process control block, or otherwise I am going to explain here itself. The next slide I am explaining the what about the process control block in depth we will discuss. Okay students, these are main differences between process and program. This table mainly differentiate between the process and program. So coming to the main differences between process and program, the most significant difference that you should note here is that a program is a set of instructions that is created to accomplish a specific task, whereas a process is a subset of a program which is created when the program is in execution. This is the main difference. The program is a set of instructions that is created but specific task, where the process is a subset of program. That's why I am giving this main difference. Process is subset of program which is created when the program is in the execution. Next slide. Now coming to the in between process and program, a process consists of a thread, but that threads are many. So that's why I'm giving the definition of a thread. A process consists of a thread. That's why thread is a basic unit of CPU utilization. It comprises a shared ID, a program counter, a register set, and stack. These are the data structures consist of a thread. So again, data structures consist of a process also, that we will discuss one by one. Okay, it shares code section, data section, and other operating system resources such as open files and signals. So this is the main basic unit of CPU utilization, that is a thread. Next, what are the various differences between again thread and process? That we will see here in this slide. Thread are easier to create and terminate, but process are not easy to create and terminate. Multiple threads, when they are in the same process, share the same address, but in process do not share the same address. Thread, it is easy to communicate between the threads. Process, to communicate between processes, we need operating system intervention. Thread, it takes less time in context switching. Process, it takes more time to context switching. Thread is a lightweight process. Each thread in the process shares code section, data section, and resources. The process is heavyweight, but thread is lightweight. So this is the main difference between process and thread. Process is heavyweight. This is the very important point. I'm noticed that thread is a lightweight. Very lightweight means it shares the code and data and resources itself, but process is heavyweight. It not share that code, data and resources. It's very heavyweight. A process, suppose this is a process. Let me take process P1. In this process P1, it's having many number of threads like this. The process consists of thread. Let me take, this is thread T1. This may take thread T2 and let me take T3. A process consists of n number of threads, T1, T2 and so on, Tn. So that's why process is heavyweight, then thread is a lightweight. Okay, next slide. Coming to this table, the life cycle of a process. So a process having a states like start state, ready state, running state, waiting state and terminate state, or it's also called exit state. The main description of this starting state, this is the initial state when a process first started or created. Next stage is a ready state. This process is waiting to be assigned to a processor. Ready process are waiting to have the processor allocated to them by the operating system so that they can run. Process may come into this state after start state or while running it but interrupted by the scheduler to assign CPU to some other process. Running state, once the process has been assigned to a processor by the operating system scheduler, the process state is set to running and the processor executing its instructions. That is called a running state. Waiting stage, the processor moves into the waiting state if it need to wait for a resource such as waiting for user input or waiting for a file to become available. The finally terminated or exit, once the process finished its execution or it is terminated by the operating system, it is moved to the terminated state where it waits to be removed from main memory. Okay, let me see the process life cycle in detailed diagram. This is the diagram of the process life cycle. New state, this is the process born in this state, that is a new state. That process admitted it going to be a ready state. That time has been interval completed, then process scheduler dispatched to running state. Once the time has been over, again that interrupt occur, again it goes to the ready state. So in this running state, if any input output event occur, again that process is going to be waiting state. If that input output event completed, then again the process goes to waiting stage to ready state. Again that scheduler dispatch, that again goes to running state. This is a loop between running state, ready state and waiting state. The process is completed for the execution, it going to be exit, then it going to be terminated stage. This is entire that life cycle of the process. Coming to the process control block. A process have a process control block. It have many data structure. A process control block data structures maintained by the operating system for every process. So every process contains its own PCB, that is a process control block. The process control block is identified by an integer called process ID. This is the first data structure in the process control block. So a PCB keeps all the information needed to keep track of a process as listed below the table of the complete of the process control block. I am given in this table the complete detail of the process control block. That first one is process state. This is the first one. That current state of the process, that is whether it is a ready state or running state or waiting state or whatever. Next, process privileges. This is the second data structure. This is required to allow or disallow access to system resources. The third very important data structure is a process ID. It is called unique number, means unique identification for each of the process in the operating system. Next, fourth one is a pointer of the data structure. A pointer to present a process. Next, very important data structure, that is fifth one, is a program counter. Means that it is a pointer to address of the next instruction to be executed for this process. That is program counter. Sixth one, next data structure is the CPU register. Various CPU registers where process needs to be stored for execution for a running state. That is called CPU registers. Next, seventh one is CPU scheduling information. Means that a process priority and other scheduling information which is required to schedule the process, which process is going to be executed next. That's defined that CPU scheduling information. Next one is a very important data structure, memory management information. This includes the information of page table, memory limits, segment table, depending on memory used by the operating system. Next data structure is accounting information. This includes that amount of CPU used for process execution, time limits, execution ID, etc. All contains this accounting information, and means that when the process is created, when the process is terminated, that is the time. The entire information consists of this accounting information. Finally, input output, 10th one, input output status information. This includes list of input output devices such are allocated to the process. This is completely detailed information about the process control block. Okay. Next, structure. What is the structure? The figure of the process control block. That is first one, which state it is the process. Either new state, ready state, running state, waiting state, terminate state. Those are the 5 or 6 states. Depends which state the present process consists of. That defines in the process states. The second data structure is a process number. Every process has unique number, unique ID that defines the process number. Then third data structure is a program counter. Means that once the process going to be executed, then which process is going to be the next, that gives the program counter. Every time one process completed, it going to be executed by the next process. So that every time the program counter is incremented by 1. Next, fourth data structures are called registers. Registers are high-speed memory internal to CPU. This is also part of the process control block. Then finally, as every process has a memory limits having specific memory sizes for the data structures, that's depend upon the memory limits. Then finally, it contains data structure consists of the list of open files, various files and various information that consist of the process control block. Okay, students, I stop in this presentation from the process. I give the entire details of the process. What is the process? How process run? What is the difference between process and program? And what is a thread? And what are the differences between a thread and process? Also, I explained. And finally, I give the in detail about the process life cycle and process control block. Okay, students, I collected this information from the books called Abraham Silver's Scratch book and William Stalling's books. I collected this information. Thank you, students.
Like, share and subscribe. Hit the bell icon for more updates.